Let's look at this shear moment diagram. This is A, reaction A, and reaction B, 2 meter, 2 meter, and this is distributed load, 2 kilonewton per meter. Draw the shear force and bending moment diagram for beam AB. This is the beam AB using the equation approach. So he wanted to use the equation approach. The equation approach, you have to find a section inside and shear up, shear down. If you go up like here, this is going to go down. This is a pull here, and the moment has to be opposite. Shear has to be opposite, and the moment has to be opposite too. This has to be positive. You should look at this. This is the positive. It's going up from here, and this is also the shear going down is opposite. It's positive too. So for the shear, if this is to the left, it's up, it's positive. If it's to the right, down, it is positive. The moment, if it's going like this, clockwise, it's positive from here. And if it's going like this, it is also positive. Okay? If it's pull, it's positive. If it's compression, it's negative. So let's understand this technique and understand this theory, and let's solve for shear moment diagram for this one using the equation wise. So we put, of course, we did find the AY, BY. This is, we did it later on. And now we have to determine the sections. This is by the equation. Let's do a cut here, and let's do a cut here, and let's find the section. So this cut here will take this side. So taking this side, it will make it like this. You have AY, 3 kilonewton, and this is the distributed load, 2 kilonewton per meter. And you have, of course, since you have a section, we will take this one as an X, and we'll do it like that. So 2 times X, so it's 2X kilonewton. And now, since this is going to be the shear down, and we're going to make it positive, and this is the moment like this, and it's a pull. And of course, since there is nothing in the x-axis, this force is 0. We're going to call it N1 because this section is 1. Now, this shear, which is down, we should make it like this one. So summation of force at Y. 3 kilonewton minus 2x minus V1, okay, equal to 0. So the shear here, the cut here is minus 2x plus 3. So minus 2x plus 3. Okay, now if you take moment at point C, moment at point C, where is point C? It is minus 3 times x minus 3 times x, moment at this point to find moment 1. This is going to go like this, minus 3x, and this is going to be positive, plus 2x times, of course, 2x times the distance from here to here, that is x over 2. 2x times x over 2 plus moment 1, because this moment is plus if it is to the right, equal to 0. You could find the moment 1 minus x squared plus 3x, that is kilonewton meter, and then shear force minus 2x plus 3 kilonewton. So we find these two equations. Now let's do the other section, because we have to find this section with the loading and the other section without the loading. So we're going to call this, of course, this is going to be in the center. This is 2 meters. This is going to be 1 meter. In the center, the 4 kilonewton, which is the loading, and this is the equivalent loading, remember. This is 2 times 2, that's 4, and it's in 1. And we're going to do the cut here, and we're going to call it an X. So this is 1 in the center, and this is the X. Of course, you're going to have the same section. Shear V2, N2 is equal to 0. There is no reaction in the X-axis, and moment 2. So we have V2, M2, and N2. N2 is 0. We'll do the same thing, summation moment at C equal to 0, and then you could find out that M2 is equal minus X plus 4. You could do the same approach. And of course, M2 is plus because we are assuming it's going counterclockwise. Summation of force at the Y, you could do it like this and find V2 is equal minus 1. Because you can see V2 is 3 up minus 4. So this is going to be 1 up. Oh, so this is 4, 3. It has to be 1 up. So it has to be 1 up. So it has to be opposite to this. So V2 is minus 1 kilonewton. So this is going to be up. The shear is going to be up. Okay? So this is one way of doing the shear and moment diagram using the equation. So now, since we have the equation, we have moment 1 and moment 2 equation wise, and we have moment 2 and V2 equation wise, we'll put the equation V1, M1 from 0 to 2 meters, and 2 to 4, we have V1, V2, and M2. So we'll draw the things. Now, from here to here, this is the equation of the shear. At here, you can do it at 0. What is the shear? You put 0, the shear is 3. So it's going to go to 3. Okay? And now, at 2 meters, what is the shear? 2 times 2 is minus 4. Minus 4 and 3 is minus 1. So it's going to go like this straight line to minus 1 kilonewton. Okay, and here, what is the shear? Minus 1. So it's going to be minus 1 all the way until it reaches this point. So you have at this minus 1, and there is the 1 here up, it's going to go to 1. So remember, here there is a shear 0. And when you have shear 0, which means that there is a maximum moment. So let's find the moment at x equal to 0 at this point. 0, 0, moment is 0. Remember, if there is a shear 0, moment is max. And if there is a straight line like this, moment going to be concave. Okay, so let's do it at this. Let's find out this. What is the distance to this one? Remember, 3, and this is 1. Let's take the whole triangle. 3 and 1, 4. 3 and 1, 4. And the whole thing is what? 2. So the whole thing is 2, and the whole thing is 4. So 4 and 2. 4 and 2, and then you could do it 3 and x. So if you do it 4, I mean the whole thing is it's 4 and 2. 4 over 2 equal 4 over 2 is 2. 3 over x. So 3 over 2, which is 1.5. So this distance is 1.5. So we could find the area under this to find out the maximum. Like 1/2 times 3 is 1.5. 1.5 times 1.5, that's going to give you 2.25. But we could find out this 1.5, if you plug it into this equation, you could get 2.25 kilonewton meter. And this is at 1.5. For 2, you could just plug it in here. You could find the moment here, which is 2 kilonewton meter. And since this is here, you could come to this moment at this one, which is the whole thing, at 4. Minus 4 and 4 is 0. You could go, but since this is straight down like this, slopey, it is concave. This is, it's the same uniform. It's going to be linear to 0. Okay?